Guys, today's video is on interpreting graphs. Instead of having a set thing of notes, we're just going to go over a couple practice examples in the skills practice worksheet together. The first thing you do when you have a graph and you're asked to analyze it and answer all these questions is just look at the title and see how the graph's basically moving in this case. So number one, we have David saving for a car. The x-axis is time in weeks, so as the weeks go on, they get bigger. And the y-axis looks like the money that he has in his savings for the car. It looks like it starts at 1400 where he's saving and then increases in a positive fashion, going up to infinity, basically. So now let's look at the questions we need to answer. We have to identify whether the graph's linear or nonlinear. Does it resemble a line? Yes, so it is linear. Then we have to interpret any of the intercepts for the graph. Basically, the intercepts, the x or the y intercepts. Does the graph cross the x-axis or the y-axis in this case? It does cross the y-axis at this point value right here. And what is that point value? It looks like it's at 1400. So we say there's a y-intercept at 1400. Let's explain what that means in terms of the graph. That means at the start of his savings, for that car, he already has $1,400. That's what that point means. Then we have to talk about whether the graph is going positive or negative, increasing, decreasing. So the graph is going positively. That means, is it above the x-axis? So positive means, is it above the x-axis? The graph is. There is no point where the graph is below the x-axis at all times. And is the graph increasing or decreasing? So the graph is going up, so it's increasing. At all times. And the last thing I want to talk about is the end behavior. What the end behavior means is that where is the graph ending up? At the end to the right, looks like the graph is increasing to infinity. So what that means at the end of the graph, so as the weeks go on, he's going to keep saving more and more money. The way we write that in a sentence is that his savings will continue to increase if he kept on saving forever to infinity. Let's do another one. Number two, let's look at this graph before we answer any of the questions. We're talking about baking supplies. The x-axis is the number of batches of cookies. Looks like you can have 0, 1, 2, 4, 6, 8, 10, 12, going up by 2s on the x-axis. And the y-axis is the number of flour, of cups. So if we're looking at this right now, it looks like at 0 batches of cookies, you need 20 cups of flour. And then it looks like it's decreasing, going down. So we're just previewing the graph before we answer any of the questions. It is linear, does resemble a line. Let's look at any intercepts. Here's an intercept here where the graph crosses the y-axis. It looks like here's an intercept here where the graph crosses the x-axis. So let's write the y-intercept is 0, 20. That means you need 20 cups of flour to bake 0 batches of cookies. Which doesn't really make sense, but that's what this graph looks like. The x-axis, x-intercept right here, looks like it's at 10, 0. That means to bake 10 batches of cookies. You're going to have 0 cups of flour. The 10 represents the cookies, the 0 represents the flour. Let's talk about whether it's increasing or decreasing. The graph is going down, so it's decreasing from the start, and then it continues decreasing until forever. You can say until infinity. Let's talk about where the graph is positive or negative. Remember, positive and negative means is it above or below the x-axis? So we can say that the graph is positive, all right, above the x-axis. So it's positive from 0 batches of cookies until 10 batches of cookies. Because if this graph kept on going down, it would then be below the x-axis. So that's why it's only positive from 0 to 10. Looks like it's going negative, judging based off that arrow. I think that's all we're going to put for this graph. Let's look at one more. Let's look at number 3, where we don't have a linear graph. So here we're talking about the height of a golf ball. The x-axis looks like it's the distance from the tee. So the tee is where you hit the golf ball from. And then it keeps on going further and further from where you hit it. And the y-axis is the height. So if we're looking at this graph, this is where you hit it, right at the tee. And it's not really any height off the ground. But as soon as you smack that ball, it shoots up really, really tall to like right here of a maximum height. And then it shoots down really quickly until it gets like about 120 yards away from you, and then it hits the ground again. Now let's write about this in terms of sentences. So it is not linear, so we write non-linear. And let's talk about the intercepts. It looks like it crosses here and here. So we have 2 intercepts at 0, 0. And we have another intercept at 120, 0. The 0, 0 represents at time 0, so at the start, it is ground level. That means it's at 0 height. And then 120, 0 means when the ball is 120 yards away, it returns to the ground. Let's talk about increasing, decreasing, and positive, negative stuff. The graph is increasing from when you hit it up until this point right here. Because at this point, then it's at the vertex, it's called, then it starts going back down. So we write increasing from when you hit it, and then up until it's about right here 60, until it is 60 yards away. Then it's decreasing from 60 yards away all the way until it hits the ground, until it reaches 120 yards away. I know this is a lot of writing, but we're just taking our thoughts and putting them to paper. Now let's talk about when is it positive or negative. Again, positive and negative mean when is the graph above the x-axis. So the graph is always above this x-axis. Here's the x-axis right here. So it's always positive. If you take a peek at number 4, you'll see a graph that has an example when a graph is negative, but in this case, it's always positive above the x-axis. You can also say, I'm not going to write this, but you can also say that there is symmetry in the graph. If I drew a vertical line right here, there is symmetry at 60. The graph is a reflection of itself, and that's about it. Let me know what questions you have on interpreting graphs. We'll do some practice in class. Have a great night.